Hello, ladies and gentlemen. Welcome back to Chapter 16, where we are talking about acids and bases. And this is part 4. Now, technically, we're not going to be talking about acids and bases so much as indicators. Now, an indicator is a substance that changes its color when it's exposed to its conjugate. Okay, remember, it's whatever either gives or receives those electrons, protons, or hydrogen, depending on who you're talking to, what type of acid or base. And that is used to indicate, which means to show, the pH of a substance. Okay? You saw it a little bit when we talked about the litmus paper back at the beginning. However, that is just kind of the tip of the iceberg. There are many different types of indicators, some of which are natural and some of which are man-made. Okay, this right here is a chart that shows basically on your left side right here, this is a list of all these different types of indicators for the most part. There's a few that are not in indicators, they're specifically stains. But if you look at the chart, basically right through here, it indicates what range of pH each indicator will cover. Okay, so like, uh, let's see, our methyl red here covers from a little over 4 to almost 7. Okay, so you're not going to be using methyl red on a base because base is over here. So the idea being that if you know what you're looking for, acid base, about what pH, you would be able to use these different types of indicators to show you if what the pH is what you thought it was. If you know around what it is. Now, the range that it shows, and this is our litmus friend here, from blue to red, that range right there is called a transition interval. Okay, that is the range that indicator has a color change. Because basically, if it's not in that range, nothing is going to happen. And you won't have a clue what the pH is. You'll just know it's not in that range, which is pretty useless. Okay, because you wouldn't even know if it's an acid or a base. Now, as you could imagine, trying to plan out which indicator to use when they all have these little tiny ranges gets kind of annoying unless you have a really specific purpose in mind and it's basically just a check. It's like, okay, it's, what I thought it was. If it's not that and you're actually trying to figure out the pH of something, this would probably drive most people nuts, trying to figure out which indicator to use. I mean, you'd be sitting there with 20 indicators trying to figure out which one to use, and you might end up using 20 of them until you get the right one. Okay, so somebody came along and they created what is called a universal indicator. And this is actually a mixture of different indicators, so you get the whole pH range. I don't know about you, but I'm very glad that somebody figured out this process. Now, you can see you have this basic range from pH of 1 to 14. Remember, there's not usually a 0. And this is what it looks like. These are the universal indicator papers. Okay, now you might be hard pressed to say, okay, is that for, is this a 3, this a 4, if you're looking at these, or, which green is, which green's a little darker, which green's a little lighter, is it just the concentration? But it at least gives you an idea. And if you wanted to get something more specific, you could say, well, okay, I have my purple colors here. I know it's down, it's very basic, so let's go use the other indicator to give a more specific amount. They also have pH meters. Kind of looks like a thermometer that's hooked up to a little mini computer, and nowadays they can just stick that in. But the paper's more fun. Okay, so we now have the universal indicators. Lots of people will use these to at least to get a clue as to what the overall pH would be. And that's an actual photograph of what they look like. They didn't use a marker on a piece of paper. Okay, so it gives a pretty good indication. Now, not all indicators are chemicals that you would create in a laboratory. For a long time, indicators have been made out of natural substances. The lab to do this is fun. It's kind of long for some parts because you got to cook some of these things. But it's fun to play with these things and to realize that they can actually do this. Now, the best indicator that most people use is red cabbage. Now, remember, it does not look actually red, and this is usually added to like a salad or something because it looks really pretty, but a lot of people don't like cabbage. Sauerkraut, kimchi. I like these things, but not everybody. Okay, so the lab that you're going to see is based off of using cabbage, red cabbage specifically, as an indicator. You are quite welcome to try this at home with permission from your parents, of course. There's really not much to it if you're just using the cabbage. He does say that it doesn't really matter what temperature of water, but the reality is the warm water or hot water really does work best. And where he talks about pouring it off, you also could use a strainer if you wanted to. But the idea is to not have too many chunks in your indicator. Okay, so here goes.
Bearded Science Guy here, and today we're going to use red cabbage as an acid-base indicator. To start with, pour about 1 to 2 cups of water into a blender. Warm water works the best, but any temperature will do. Now place 3 to 4 leaves of the red cabbage in the blender as well. Tearing the leaves into smaller sections will make it easier to blend. Now turn the blender on for about 30 seconds to a minute, or until the leaves are chopped into very small pieces. What we're after is the molecule that gives the red cabbage its purple color. So very carefully pour off the liquid, keeping the pieces of cabbage still in the blender.
Remember, you could use a strainer.
This dark purple liquid is your acid-base indicator. Acid-base indicators change color according to the pH or acidity of a solution. For example, a bright green color indicates a pH between 10 and 12. A bluish purple color indicates a pH between 6 and 8, and a pinkish red color indicates a pH between 2 and 4. These colors allow you to begin experimenting with acid-base chemistry. For example, if you take the neutral solution and add acid to it, you see that the solution turns pink, indicating that it is now acidic. However, if you now take a basic solution and add it to this acidic solution, it slowly turns back to a purplish blue, indicating that the base neutralized the acid. You can now begin designing experiments of your own, where you can visually see acid-base chemistry happening before your very eyes. Thanks for watching Bearded Science Guy. For weekly science videos, click here and subscribe to our YouTube channel.
Subscribing there won't work. You actually have to go find him. But you can see that it's fun to play with. It's really easy to make. You don't have to cook it. Warm tap water works just fine. But it's really best if you use a strainer or something because it takes a while to separate out the solids from the liquids, depending on how much water you use. Now, cabbage, as you saw, is not the only thing. If you desire to do this at home, you can use this as a color guide. You can see he obviously did not go through all of the colors. And of course, there's variations on all of this. But the substance that is in the cabbage that does this is what's called flavin, which is an anthocyanin, which is an antioxidant. Remember, they get rid of the free radicals, keep you healthy. And it's a pigment. It gives the color for these red, purple, and blue plants. Things like blueberries and apples, cornflower, red onions, all of those things have this same chemical called flavin. Okay? It is really fun to do. Feel free to do it. Again, with parental permission. And you can test different things like bleach or cleaner solutions and things like that. It is easiest, of course, if they don't have a whole lot of color to them, because that'll change the color that you see from the indicator itself. Okay, well, I will talk to you next time.